Greetings, the Astro 30 here yet again, and welcome back to AEL. Welcome. Now, sitting on the desk here is a Playmaster Pro Series 3 power amplifier, and it's a stereo unit, and this was sold as a kit back in the 90s. This one's probably around about 1995 and was published in the Electronics Australia magazine back in the day. This is actually the Mark II version of the original, and I'll go through what the differences between these two were. And the original was published back in 1994. And I did manage to find a scanned by somebody, which is great, schematic of the original. And there's only a few little, probably slight, subtle changes on the PCBs between the original and this version, so the schematic is still valid. So this does work. It powers up and it does produce an output signal on both channels. However, the left channel is weak and distorted, plus the clip light comes on for no apparent reason. So there's a definite fault with the left hand module. Now, I'm not going to put a lot of time into this because this belongs to my housemate, and it was basically said, well, if you can fix it, great. If not, I'll just sell it as it is and just say it's got a bad left channel. But we'll open it up and we'll have a look inside the unit, and then I'll explain what the differences between the Mark I and the Mark II version of this is. So here's a good look inside the unit, and that's the right hand module and this is the left hand module. Each has its own power transformer or power supply, and visually it looks like these transformers are slightly off, so they're not directly in center with each other, so it might have been drilled incorrectly, but whatever. And that's something you don't really see very often, is what looks like an X2 rated capacitor at 100 volt DC, 1 microfarad. That's the input capacitor, and I don't think that was how originally what was supposed to be there. Someone's added that for some sort of audiophile upgrade, which you're not going to get any sonic benefits from using a capacitor this large compared to, say, like a standard 100 volt MKT style capacitor. And we've got one of these nasty polystyrene capacitors there, which I do not like. But if we take a closer look down here, we can see where these two large 1 watt 100 ohm resistors are. Well, the board underneath is charred. So the other module uses just your standard half watt 1% metal film resistors here. So the original ones must have been getting really smoking hot, literally to the point where they just completely burnt, possibly caught fire, and that was the end of that, and damaged the circuit board. So to correct the problem, they used 1 watt devices here instead, without probably addressing what the initial problem was. They may have done when they did this repair, but it looks like, well, obviously there was way too much current being dissipated through the original resistors, so they just went up in smoke. So it's possible that this module might have been oscillating at some point, which caused it to smoke these resistors. I believe these two resistors are part of the current mirror to the voltage amplification stage here, which is a differential style VAS using 2 MJE340 transistors. So yeah, I'm not sure what happened to it, but it did actually burn the board. So the differences between this version and the original was, the front panel was the heatsink, and it had fins on the actual panel to radiate the heat. Both modules were mounted to the front, so they shared the same heatsink. Still had 2 separate power supplies. And the other difference was that they used TO3 output transistors instead of these, which I think are TO218s. They're MOSFETs, so this is a MOSFET output amplifier. So they saved some space by using, well, the TO3P style transistors rather than the TO3s. That's the only differences I could see, apart from maybe a slight layout change between the original boards. But I digress. What I need to do is I need to put this on an oscilloscope with both channels being driven with the same input signal, measuring both the left and the right outputs, so we can see what the differences is between the right channel, which is working, and the left channel, which is not quite working correctly. So let me get set up with a dummy load and oscilloscope and signal generator and find a way of injecting the signal into both channels at the same time, and then I'll check back with you. Well, I suppose it would be a good idea first, before loading it, is to check what our DC offset is on both channels, just to make sure. I've already done it off camera before, but I'll do it again on camera. So I've got it going through a dim bulb, so I'll turn it on. Well, actually, the dim bulb was bypassed, unfortunately, but nothing unusual happened. When I start getting into testing, I will put the dim bulb back in circuit. So I'll just measure across each output. This is the left-hand channel, and we have about 26 millivolts DC offset, probably a little bit high. As for the right channel, nothing. Okay, so there is our first clue that the DC offset on the left-hand channel is slightly higher than the right. Okay, so it's pretty safe to assume I can load it. So that's what I'm going to do next, and run some tests. So let me get set up for that, and we'll come back in just a second. Okay, dummy load is connected, and I've got both inputs bridged together there, and it is turned on, and we are getting an output, and it does look relatively clean, and they both look relatively the same power. Now, the top trace is the right output channel, and the bottom one is the left. But I can't see. Oh, there it goes. And now the channel has recovered. Yeah. And the clip light on that side is illuminated. So if I up that voltage per division, that's what the left channel is producing. So either we've got a faulty transistor and it's moving around all over the place, and then it recovers, or we've got a faulty resistor. Because now it doesn't seem to want to there it goes. Well, that's an interesting one, and that's going to be a lot harder to fault find. There's not any magic smoke going on, and there's a bit of warmth going into the heatsink bracket at the moment. It's about the same as the other side, so that's not an issue. As for these resistors, no, they're not getting hot. I've got to be careful. There's like plus minus 75 volts running around in this thing. There's got to be a faulty component on this board somewhere. Not sure at this stage. What would probably be a good idea is for me to measure the power supply rails between both amplifiers, just to see if they're the same. Okay, so I've got my negative probe grounded to the chassis. So all I need to do is just measure across the inputs going into the board here. So this is the negative supply rail. Yeah, 70 volts odd there. Okay, the positive supply rail, 70 odd volts. That's the left hand channel. Now for the right hand channel, the positive side, the same, and the negative supply rail, the same. So it's not a power supply issue at this stage. It's something to do with the circuitry on the amplifier itself. Now it could just be a bad solder joint, or it could be something related to where those two resistors burnt up in the first place. But what I should do now is we'll look at the circuit diagram for this. Okay, so here is the schematic diagram, which is to the original version, not the current version I've got. They're using BC640 transistors as the input stage long tail pair. However, in this current version, it's actually BC556B, so yeah, there is that. They've given us some voltages across things like between the constant current source to the long tail pair across that 22k resistor. It's a pretty standard looking amplifier. It's got a MOSFET output stage, as I already stated. They're the degeneration resistors, which we cannot see on the top surface of the PCB. That's because they're soldered underneath, which is kind of wank, but they must have done that to make the top side of the PCB look cleaner. Got a bias servo over here with what's known as a differential voltage amplification stage with a current mirror on the positive side to that voltage amplification stage, but we don't have a current mirror in the input stage. We've got a little bit of DC decoupling going on here to isolate the, I guess, high gain input stage, if you want to call it that, from the output stage transistors. And there are actually no driver transistors to the output devices. It just comes straight off of the voltage amplification stage through the bias network and just drives the MOSFETs directly, which is okay. I guess you could say that that's fair enough. Over here is the clipping detection circuitry, which just consists of two transistors with one point A connecting to point A over here, which is on one side of the bus, and point B, which is, well, the positive rail that's decoupled with the 100 microfarad capacitor, 100 ohm resistor, and this 1N4004 diode. So having these voltage measurements is kind of handy. So I can go through and measure across certain points in the circuit to see if it matches up with the schematic. Now, being that this is a revision of the original, which is the original, some of the voltages may vary. So other than that, there's not much really to talk about this schematic diagram, so I think I'm going to at least try, I can't guarantee, but I'm going to try to find out what is wrong with this thing. So that's a look at the schematic. It's pretty simple. Now, I don't think we've got a bad output MOSFET, because from what I'm seeing on the scope, it doesn't look like it. What I am wondering is, do we have a issue with heat, i.e. we've got a faulty transistor? I believe these two transistors, which looks like they're glued together with some heatsink compound, form a long tail pair, because I believe the resistor coming off of its base on this transistor on this side comes off of the output point, which is going through this green wire, which is just off to the left here to the output socket. So I believe that's our feedback takeoff point. So I'm wondering if we've got a faulty transistor here in the input stage, because that would account for, with the input sensitivity being dropped down, that it starts to correct the signal. But when it starts to heat up, well, it's no longer able to correct the signal. So I'm going to start with an old method of freezing those two transistors whilst watching the scope to see if anything changes. So yeah, I'm going to spray it. Okay, interestingly, well, the signal is moving around a bit. So I'll try another transistor down the stream. Right. Ooh. Interestingly, it's now corrected. Huh. And it's these two transistors up here that I just sprayed. Interesting. So if I just carefully hold my finger on there to warm them up, because I believe that they're the current mirrors for the input stage. And not much appears to be happening. I can't seem to get any heat into the transistor either, or transistors, but oh, there it goes. Alright, so let me spray those two transistors again. And it's corrected. I think one or both of these transistors may be faulty. So, what I'm going to do is I'm first going to power the thing off. Well, that's interesting too. Let's turn that back on. Look what happens to the left channel, the bottom trace, when I turn it off compared to the upper trace. So what I think I'm going to do is I'm going to have to pull this amplifier module out of the case, and I can't take the bottom off because the transformers are obviously mounted to the bottom plus the bridge rectifiers, but I should be able to unscrew the heatsink from the bottom of the chassis and the front panel here and get enough room to tilt the board over so I can just have a look at the underside. That's going to be the next thing I'm going to do, is look at the underside, and then I might replace these two transistors just for good measure and see if that makes a difference. If not, I'll replace the two input transistors. Oh, that was easier than I thought. The module is now flipped over. This is an underside look at the PCB. Here's the degeneration resistors for the source and drains of the MOSFETs. I'm not seeing anything unusual like with bad solder joints, although this transistor has been non-snipped. They've left the lead length completely long there for whatever reason. They may have just forgotten to snip them, but I'm not seeing any bad joints. Over here is where that original input capacitor would have been. These 2 points here would have been where the capacitor went, and that larger pad was the actual input point. And it looks like we've had a few boo-boos, like here and here, where it looks like some tracks went open and they've put some bodge wires in to fix the tracks. Yeah, so this particular module's experienced something really catastrophic in its day. I did trace out the circuit with a multimeter from those two transistors, and they do go back to the long tail pair as the constant current source, and I've lost my multimeter now. Here it is. So what I'm going to do is I'm going to just check the continuity of those bodge joints to make sure that they're still connected. Yep. Yep, indeed. Right, so I don't see anything here like bad soldering wise, so I reckon it's more likely just a faulty transistor. I mean, I could do voltage measurements on this, but I don't think that's going to really yield me much. Anyway, that's kind of irrelevant at this point. What I want to do is I want to change out those two transistors and see if that makes a difference to the operation of the circuit. Hopefully it does, because I don't really want to spend too much time on this. Well, the two transistors are replaced, which were a bit of a bugger considering that whoever assembled it in the first place bent the leads over at right angles flat to the board prior to soldering, which made it awfully difficult to remove. And the base pad on this transistor here started lifting off the board a little, so it was very, very delicate. And in the moving of the board around, the clip LED has come unglued from the front panel, which is understandable because it was only glued in with contact adhesive. But anyway, it's plugged back in, loaded, input signal is going in, and I want to see if I fixed this or made it worse. So dim bulb is in circuit, not bypassed. So I'll turn the dim bulb on and turn the power switch on. It doesn't look like I made any bit of difference. So I'm wondering if it's the input transistor pair that are bad. Oh, it's just come back up now. That's interesting. And then, yeah, it goes to shit again. So yeah, I'm not really sure what the issue is, unless it is the actual two transistors for the clipping detector. Nothing's coming out. There we go. No, it's not those transistors. Just check my new ones. Doesn't appear to be the issue, right? The input pair. Yeah, there is. Yeah, this one's a difficult one. I'm running out of free spray too. It looks like it's snowed on the board, but it hasn't corrected the input signal any. So, yeah, that's a bit of a pain in the ass. So, there's some issue still with the circuit that I'm not seeing, and that's on the wrong voltages per division. Yeah, that's better. Yeah. Might be in my best interest to replace the input transistors as well now. Just to make sure. Other than that, I'm not sure what's going on. I might just do a preliminary check of all the resistors to make sure that none are open as well. I don't think it's a capacitor, but it could be. But I'll excuse me, check all the resistors, make sure that they're still resistoring, and then I'll move on to figuring out maybe changing the input pair and see if we get a different result. Alright, it's a couple of hours later and I've been through this with a fine-tooth comb. I've changed the input transistors, didn't do anything. I even changed the capacitor and the feedback, negative feedback path to ground, didn't do anything. The old one measured 60 microfarad. It should be 47. But that wasn't the issue either. I have double checked that the signal was passing through this large capacitor correctly to the other side, which it is. The signal's clean, so it's got nothing to do with this input capacitor or anything stupid like that. I've checked all the transistors that I haven't changed, like the voltage amplification stage transistors and their current mirror transistors, and that is starting to get quite warm, yet the other channel is running cooler. So yeah, something here is drawing a bit more current than it needs to. And I have gone through, measured all the voltages and compared it to the schematic, and they all check out. So it's saying that everything is peachy keen, which has got to be crap. It's got to be. So yeah, I am not sure what the issue is here. I'm not going to start replacing, you know, these MJE series transistors or anything. I'm still adamant that the output stage transistors are fine, because otherwise we wouldn't have an output at all. That is pretty much all we're getting on the output of the left-hand channel, about 739 millivolts RMS compared to 1.78 on the other channel. So yeah, there is an issue somewhere and I don't know what it is, and I don't really want to spend too much more time on this because I've checked all the obvious, even around where this burning is. I've checked voltages there. It drops down by about 3 volts to the input stage circuitry on both sides, so it's not a lack of voltage to the input stage. All the other voltages measure correctly, or close to them. So I have absolutely bugger all idea. I'm at a loss now. So there's not much more I can do to this except glue these LEDs back in, because the other one, clip indicator, has come out of its hole as well. So yeah, glue the LEDs back in and put the thing back together, because I'm not going to really get anywhere with this, because that is getting more hotter than that one. Alright, well the heatsink's been screwed back in and I've re-glued the LEDs back in for the most part. They're still feeling a little bit sloppy, but yeah, Araldite probably would work better there than hot glue, but because this is touching the heatsink surface, so the heat's just going to probably melt the glue again. But yeah, unfortunately I can't really find the problem with this one, and considering the damage up here, it's anyone's guess as to what's going on. But as I say, all the voltages measure out correctly, so I don't know. The only transistors I haven't replaced are the ones here in the clipping detect circuit, or the driver, well not the drivers, but the constant current, well, current mirror and VAS transistors, or the output stage. I mean, we could have a faulty MOSFET on the output, it is possible, but I doubt it. Yeah, so I don't know. So unfortunately I'm going to have to leave this one in limbo because I don't know what the issue is. I can't figure out said issue. So I'm probably just going to leave this one alone from now, unless anybody else watching this has any other idea of where I can go now. I mean, please excuse that, I was picking stuff off the floor. Yeah, just leave a comment below with your thoughts. But yeah, so nothing I'm doing to this is improving the problem. If anything, it's kind of making it worse. So that's going to be it for this video, unfortunately, but I really hope you did enjoy watching it. I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, thanks for watching, have a great day.